Let's write the equation for the reaction between potassium hydroxide and phosphoric acid. This is a type of double displacement reaction known as a neutralization reaction between an acid and a base. Start by writing the formulas for these compounds. Potassium hydroxide is KOH. These ions form in a 1-to-1 ratio, and compounds that contain potassium or alkali metals are soluble, so put AQ there. And phosphoric acid is H3PO4. We need 3 protons there because the phosphate anion has a 3 negative charge. In a double displacement reaction, we're going to switch out the cations and anions. So in the products, I'm going to write potassium paired up with phosphate. Now, phosphate again has a 3 negative charge, and potassium has a 1 positive charge. So the ratio between those is going to require 3 potassiums for every 1 phosphate. And like I said earlier, compounds with alkali metals, potassium, sodium, lithium, and so on, they're all soluble in water. The other compound is going to be hydrogen with hydroxide. That's just water. But oftentimes in double displacement reactions, rather than writing water H2O, writing it HOH oftentimes makes it easier to balance, and water is a liquid. So now let's balance the equation. So on the reactant side, you're going to have 4 components, the 2 cations and 2 anions. You have potassium, hydroxide, the hydrogen from the acid, and the phosphate. Now on the product side, I'm going to put them in the same order. 3 potassiums, 1 hydroxide, 1 H from the water molecule, and then 1 phosphate. So let's put a coefficient there in front of the potassium hydroxide so we can balance out the potassium. And we'll update the hydroxides as well. Over to the product side, let's multiply where we see hydroxide by 3 by putting a coefficient where we see in front of the compound where we see hydroxide. And that's going to also update the H. So this is your balanced molecular equation for the reaction between potassium hydroxide and phosphoric acid. Now in another video, we'll take a look at how to rewrite this as a net ionic equation with a weak acid.